I know that for a lot of people, you have forgotten how to do this. At some point, like literally in third grade, somebody taught you how to do long division. And there's two groups. There's three groups. There's some of you in here that'll be like, that's easy, I can do it in my sleep. Other people who never learned it, like I never got it, and then finally they let us use calculators, and so then I was okay again. And then there's this in-between group that was like, I knew it, but I have forgotten it. So all of us need to be on this because let me show you why we need to divide numbers, because you're going to have to divide polynomials. So just let me show you what a typical problem looks like. Let me think. Like that. It's long division, but with variables and stuff. Do you get why it'd probably be good to know how to do it with just numbers first, to remember how to do that? All right. So would you please put the 213 on the inside of this big, I like to think of it as a house. Okay, so we put the 213 in there and put the 4 on the outside. Let's see if you just remember how to do it. I'm going to just not say anything and see if you can do it. I want to know what percentage of you are like, yeah, that was easy. I'm good. I got all the steps and I know the answer without a calculator. You might be thinking, we'll have calculators on the test. Yeah, but the calculator can't do, when there's variables in it, they won't be able to do it. So you have to know how to do this with just your head. How many of you have a chance? Raise your hand if you have a chance of being able to do this right now. All right. Thank you. So, I shouldn't make everybody wait because there's literally only 2 kids that feel like confident that they can do this. So I want to give you hope. For most of you, you learned this at one point, which means it'll only take a second to remind you and you'll be back good. For others that never understood it, do you realize that you were like 8 when they taught you this? Do you realize that 16-year-old, I know you're not all 16, but 16-year-old you is way smarter than 8-year-old you. And just so you know, let's say you are 16, 25-year-old you is way smarter than 16-year-old you, just even by just age. Because your brain matures, you get more coats of myelin on your brain, which is what makes your brain gray colored. Like when a very young baby doesn't have a very gray brain. By the time you're 25, you got a whole bunch of coats of myelin, and the myelin is one of the things that allows you to think faster and smarter. Basically, you're going to be smarter older you are. So my point is this. If you never got it before, you're way smarter than you used to be. You can get this. By the end of the hour, it should be easy peasy. All right, so watch how I do this. Does 4 go into 21? Well, yeah, but not perfectly. But still, you got to get as close as you can without going over. So 4 times 5, and you'd write the 5 here. Everybody do this with me now. 4 times 5 would make 20. And I draw a line. And then I'm going to say this different than you used to say it. You used to say, and then you subtract. I'm not going to say that. I'm going to say make this the opposite of what it was. Because later, when it's polynomials, sometimes they're negatives, and you'll change the sign to the opposite. And it'll turn from negative to positive. In this case, it's positive, so I made it negative. So this is change the sign to the opposite. Now we put these together. I'm not going to say subtract because sometimes it'll be 2 positive numbers and you actually will add them. So combine them together. I know in this case that means it's going to be like subtract, and so you'd have a 1. Okay, you with me so far? Then, do you guys remember that there was this thing where you drop this number down? Does that ring a bell? You remember seeing that in the past? Okay. So then, the question is whether 4 goes into that. Well, yeah, it's got something to have a leftover, though. I'm going to go 4 times 3. It makes 12. Notice it's this times this. Makes that. Then you draw the line, and then you make it the opposite of what it is. I'm not going to say subtract. I'm going to say make the opposite, because sometimes you'll have 3 signs across here, and you'll make them opposite, opposite, opposite. Opposite of whatever they are. There's a 1 left. Does anybody remember the name for that? Remainder. Very good. So this, we're not going to test you on that word. That is called the dividend. This, we're not going to test you on that word. It's the divisor. But we are testing you on this word because we're going to say, list the quotient here. That is the quotient. Quotient. That's called the quotient, and that is called the remainder.
Are we not going to turn the remainder to a decimal?
No, we are not going to make a decimal because, think about it, if you have a decimal in polynomials, that's not going to make any sense. You don't have like a decimal point x plus 3 or something. So yes, it's true that you can go further with these, and you did when you were younger, but we don't even need that. We can stop with the remainder right there. In case you want to remember what it was, you put a 0 and you put a decimal point, and then you put a decimal point up here, and then you bring the 0 down, and you keep going, keep adding zeros until you finally finish. But we're not doing it. So the quotient was 53 and the remainder was 1. And just in case you forgot what the whole point of divide is, it's to turn it into 4 times 53, but that's not the exact answer you want. It's 4 times 53, and then you're going to be 1 short. So you add the remainder at the end. You know, it's these two are here and here, plus 1. Okay. I know. We went from only 2 kids feeling like you had a chance to now I think probably half of you have a chance. Let's try this. 3 goes into 29. You need to know each little step because when it turns into algebra in a second, the only hope you have is that you know all the steps from when it was easy. So does 3 go into 27? Yeah, 27 is really close to 29. So 9 times 3 makes 27. Now, if you're one of those kids that struggles with multiplication and stuff, remember, we're going to have like a little paper chart, just like we did on that one test. That'll be available if you want to use one of these little paper charts. That's a multiplication chart. And there's also a calculator allowed. So you could just go 3 times 6. Oh, that's too small. 3 times 7, 3 times 8, 3 times 9. 27. Draw the line. Make it the opposite. Then there's 2 left. So what's the quotient? What's the remainder? 2. There you go. Quotient's 9, remainder's 2. All right. No, you just leave it just like that. That's all you got to do. And then you're going to have a blank on the test that says, what's the quotient? And you'd say 9. And then you're going to have a blank on the test that says, what's the remainder? And you'd say 2. Now, it is true that 9 times 3, or 3 times 9, doesn't matter, plus 2 is equal to all that. And it's good to know that, but that's not required that you write that. Okay. So what if this is really long? It's the same process. Does 3 go into 1, 0, 1, 2? And I'll give you a hint. There's a remainder at the end on this one. So 3 does not go into 1012. Seems like it might because there's a 12 at the end. Doesn't work. But there's a remainder, and the whole point would be to tell what the answer is for the quotient, like what goes on top, and what's the remainder that you get at the bottom. I'll start. 3 times 3 makes 9. Draw a line. Make it the opposite. Go for it. I have no problem with a hood, but you got to show me your ears to make sure that you're not using that to hide. Okay, cool. Hide. Oh, ouch. Sorry, my hip still hurts me. So I'm just looking for headphones. Okay. So 10 minus 1, 9 is 1, and then I go where I'm kind of lost. What do I do? You remember? Bring down the 1. Good. Okay. And then I go, does 3 go into 11? Yeah, 3 goes in there 3 times again. 3 times 3 is 9, and this time there's going to be, make it the opposite, 2 left. Bring down the 2. Does 3 go into 22? Yeah, 7 times. 7 times 3 is 21. 1 left. That's the remainder. This is that Q word again. What's that called again? Quotient. Quotient, 337. Remainder, 1. And what it means is 337 times 3 plus 1 equals this thing, which I told you didn't have to know the name of. It's called the dividend. All right, cool. Now, if you understood those steps, now we have to extend that to this. Find this page. It's page 2 of the notes. And you have to be able to divide it when there's variables. Now, for some of you, honestly, I'm just being honest here. If your best score last semester was a C on the test, okay? This is hard. It's got so many little steps. You got to remember the negatives. You got to like do a ton of little steps to get an answer. If your best score last semester was a C, you might not get this, and it's okay. Like, I want you to get that just because you might not get this doesn't mean the test on Thursday that you're going to fail. But I will say, if you want an A in this test, you'd have to know how to do this. I don't think you could get an A on this next test without knowing at least how to do one of these. Okay? So if your goal is an A in this class, try your hardest to learn this. If you're getting freaked out because this is impossible for you, you can get a C on this test without knowing how to do this. All right. Here's how you'd start. The x minus 5 goes on the outside. The little number goes on the outside. The big number goes on the inside. X to the third minus x squared minus 26x plus 30. Okay. So there's the setup. You got to know that, which is basically a small number goes on the outside. Okay. Now, watch an expert and listen to like how you think this through. Always start with an x up here. That's going to be the beginning of your dividend pretty much every time. But just because we start with an x doesn't mean that's the only thing that goes up there. Otherwise, it's going to be incredibly easy. So how do you tell if that worked or not? You're going to, just like last time, where when I had like a 3 going into 20 and you'd go, I think it goes in there 6 times. You did this times this and you put like an 18 there, right? We're going to do the same thing. We're going to do this times this, and then we'd get an x squared. But wait. When I subtract later, do you get x to the third and the x squared aren't going to cancel each other? So x was close, but it really needed to be x squared here so that this would be x to the third. Okay, so this is really key. I want to make sure you get this. The whole point of what you pick for here is that when you multiply it by here, it makes these two match perfectly. If those two match perfectly, then they're going to cancel each other out, and that's how we keep moving across and getting it all the way to the end, and finally at the end you'll get rid of the 30. All right, so how did I pick that? I started with x, realized it wasn't enough because I did this times this, and I was only getting x squared. Then I made it x squared, and so now x squared times x makes x to the third. Then don't forget to multiply it by this. So x squared times the minus 5 makes minus 5x squared. Then draw a longer line than you would need to. I've done a lot of these. This helps keep you organized. Draw a line all the way across like that. And now, you remember me saying I'm not always going to multiply? It's because you're not. Sorry. I said you would not always subtract. That was what I said. See, you make it the opposite of what it was. So this becomes a minus, and that becomes a plus. This is how it's different than the simple kind. All right, so I now have made it a negative and a positive instead of a positive and a negative. So I switched their signs. Now these guys are exact opposites, and that was the whole point. They will cancel each other. Yay. The next two, remember how I said don't think of this as subtract because it's a negative plus something? It's not really subtract. But it's combining those two, and I get positive wins because I got only one of these. So it's going to be 4x squared. Now, let's go back to this thing again. And what would happen when you were done? You'd bring down another number. Bring down this. Negative 26x. All right, remember me saying you always start with an x, and you see if it worked. It's close. X times x does make x squared, but it didn't make 4x squared. So do you get how it was close, but I got to make it a 4? Because I want this to come out to 4x squared here. 4x times x would make 4x squared. And even though we know that a number that we don't put a sign on means positive, you need to put a plus here. Right? Plus 4x. All right, so now 4x times the other number, 4x times the negative 5 makes negative, 5 times 4 is 20x. Draw the line longer than you'd think. Now, right about here is the part where a lot of times kids just forget to put in the opposite. This is very tedious. You got to follow this exact process for making it work. Hey, life has a lot of moments like that. You want to type in the password for your home security system? Oh, is this off by one number? Well, it's going to set the alarm off. You got to be exact. All right, so now this and this. Again, this is why I don't want to call it subtract, because like that's not really a subtract. But I'm combining negative 26 and positive 20, and I get, let me think, the negative team is bigger, so it's negative 6x. And I sometimes think, kids with a calculator sometimes think they can't do this with a calculator because it has an x on it. But you can actually type in negative 26 plus 20, and the calculator will do it. Negative 26 plus 20 will give you negative 6. And you just have to be smart enough to throw the x on at the end. Okay, and then I'm dropping the 30 all the way down. And pro tip, just something I've noticed after doing a million of these. If this will factor, do you get how there's a 6 in both of them? If that will factor, then it's probably going to work, and you're probably going to get a remainder of 0 at the end. You don't have to even notice that. Just telling the extra, like, straight A students that might appreciate that. If it factors at the end, that means it's probably going to work. All right. So then what do I put up here? Always start with an x and realize, wait, x times x is going to make x squared. I don't want an x squared. That doesn't make sense. And then you adjust and go, well, and it can't be an x. Probably a 6. And even more than that, a negative 6. Because I want a negative 6x. At the beginning, you want to exactly match this and this, exactly. Because later you'll change the sign of the second one, and then it'll make them disappear. Okay, and now the negative 6 times the negative 5 makes positive 30, and look at that. It all matched perfectly. That way when I go through and do opposite, these two will cancel and these two will cancel, and I have a 0 remainder. You don't think so, huh?
Negative 6x and then plus 6x squared.
Okay, so I wrote x squared, but it's not an x squared. I did that at the beginning to, yeah, that was my mistake in how I wrote that. But they do cancel. Negative 6x cancels the positive 6x, and now they're gone. Okay, so final answer, this thing up here is called the quotient. I know it's messy, but I think you can still read it in there. X squared plus 4x minus 6. And this thing is called the remainder. Now, that's the first serious one that we've done. That's the kind that we test you on. If you don't get it yet, that's okay. I just taught you it. It's the first time. We'll practice it again tomorrow. That's Tuesday. The next day, which is Wednesday. And then the test is Thursday. So you got a couple days to figure this out still. All right, please go to this page. We're going to kind of do every other one or something. We're going to go to the bottom of this page. This problem right here. So we're going to put the x plus 3 on the outside. We're almost done, ladies and gentlemen, but don't just sit there and watch me do this. Copy this problem down. If you just watch, you aren't learning anything. Realize you only remember 10% of what somebody tells you? Okay, got that copied? I'm going to ask a few kids now for the things I've tried to teach you. So Pierce, for example, what did I say to always start with on the top there? X is correct. But then it oftentimes needs to be adjusted because you get x times x makes x squared, and that's not at all what we want. So Pierce, what do you think I should adjust it to? X squared would get us up to x to the third, which is close. X to the third. That way when I times it by x, I'll get x to the fourth. And that's close. Max, what do you think it really should be? Not just x to the third. No, if I put it x to the fourth, then this x will make it go x to the fifth. That's not what I mean. Hint, it needs to match this exactly. It needs a 2 in front. 2x to the third. Who had 2x to the third before I said it? Okay, good. A lot of you caught that. 2x to the third works, because then when you times it by this, you get 2x to the fourth. Then don't forget to times it by this, plus 6x to the third. Drawing a line longer than you'd think. Helps keep us organized. Did you remember the opposite step? If you didn't put negatives on both those numbers, you're doing it wrong. That makes negative 4x to the third. Kai, you know the next step? Oh, it's not Kai. My bad. Okay, I'm going to go to Hannah Lyle. Can you tell me what the next step is? Yes. Negative 3x squared comes down. Josie, do you remember what I said you always start with up here? Yep. And x times x makes x squared. And then you go, okay, that's not enough. Oh, yeah, I make it one bigger. X to the second. That way, when you times it by the x, you'll get x to the third. And then I'm close. But then I really want it to be negative 4x squared so that I get negative 4x to the third. Now, these two match. That's the whole point, is make this and this be exactly the same. And then you know you're on track. So this negative, that negative is looking a little messy. I'm going to clean it up. Negative 4x squared is now going to get times by the 3. And that makes negative 12x squared. Draw a line longer than you'd think. Opposite. Opposite. Look at that. Now it's actually both pluses on the bottom. Because I made both signs the opposite of what they were. And these two cancel. Sweet. And then this is positive 9x squared. Because 12 and negative 3, if you were terrible at basics like that, you just use a calculator. Go negative 3 plus 12. It'll tell you the 9. You gotta slap the x squared on. Okay. Then it's like this isn't big enough down there, so you bring down another one. Plus 19x. Then you always start with an x. X times x is x squared. It was really close. Turns out I needed a 9 to make it 9x squared. Then you times by the other one. The 9x times the 3 makes 27x. Draw the line. Opposite, opposite. Positive 19 and negative 27 makes negative 8x. One last number to bring down. I gave a pro tip earlier that if this factors, it's probably going to work, and it does factor, which means we probably have a 0 remainder at the end. Just got to figure out what number to put on top. Say it if you know it. Negative 8 is correct. Good job. Negative 8 times the x makes negative 8x. And the negative 8 times the 3 makes negative 24. Look at that. It's working. Don't forget the opposite even at the end, because these have to be opposites to cancel and make 0. Cool. 0 remainder. Now, what you may not have processed yet is that we just factored this into x plus 3 times all that. That was factoring. Like, now we know that it factors into these two parts, plus a 0 remainder, which doesn't really do anything, right? So 2x to the third, I'm just copying from up here where the quotient is, minus 4x squared plus 9x minus 8. And why am I writing that? Because tomorrow, the last thing I have to teach you is that when you're done with a long divide like this, you've just figured out this, you factored it, but it just isn't factored all the way, and then you could do one of those like factor by grouping things and finish it off. So it's like tomorrow's job is to take these two things you just got out of your divide problem and factor it one more time. All right, so that's what's tomorrow's lesson. So for today, it's just about, can you get these two things? The quotient, and that's technically called the divisor, but we don't test on that. You do have to know the word quotient. They'll ask, what's the quotient? What's the remainder? Okay, last page. And we're not going to do any with missing terms. Let me explain that. Look at this bottom one. Goes x to the third, x to the second, and there should be an x to the first in there, but there isn't. We're not going to mess with those today. This is hard enough to not, we're just not going to do that kind. Okay, so I'll tell you tomorrow how hardcore we have to be. Like how do you have to know that for the test? For right now, I know you don't need to know it for today's homework. All right, so let's do this last one together. The x plus 2 goes on the outside. The inside is this. Now, I noticed a kid grabbing for a cell phone earlier. Please don't do that. I have to write a letter. You have to get your mom and dad mad at you because Mr. Server had to write the letter. In the end, we can all blame Mr. Erickson, but more you taking it out during class. Just wait 5 more minutes. We're all done. All right, so here we go. Always start with an x right there. Often it has to be added to, but x times x makes x squared. Okay, that's definitely not enough. X to the third would be enough to make this x to the fourth, and then also a 2. So then it's 2x to the fourth. Cool. These two numbers perfectly match. When they do, you know you're doing it right. Okay, now I go this times this. And that makes plus 4x to the third. Draw the line longer than you'd think. Opposite, opposite. Perennial favorite for kids forgetting that on the test. Two kids came up for help last hour, and they both had made that mistake. It's just so easy to forget the opposite thing. Okay, so this x to the third minus the 4x to the third makes negative 3x to the third. If you are terrible at that kind of thing, use your calculator. Do plus 1 minus 4. And they'll say minus 3. X to the third. Bring this down, minus 4x. Now I need an x up here to see if that works. X times x is x squared. That's not enough. I need this to be x squared. So it'll be x to the third. And the x squared needs a negative 3 on it, so that I get negative 3x to the third. And then I'm going to times it by the 2. Makes negative 6x Oh crap, this one has a missing term. I'll show you what to do. Squared. Okay, you draw the line, make it opposite, opposite. They were both negative, so now they're both positive. This cancels off just like it's supposed to, but that just got weird because it's, unless I copied the problem down wrong. No, I didn't, unfortunately. This went to the fourth, to the third. That should be to the second, but it's not, and I was going to not show you this kind. But I guess we're this far. I'm going to show you what to do. So we're right here. Do you get that those are not like terms? Then all you have to do is copy them down in the right order with the bigger one first and say 6x squared minus 4x. You see what I mean? It's a minus because there's a minus here. And the bigger one is this one because it's got a bigger power. So look, they're just not like terms, so you just put them right next to each other. And then you just keep going in the problem like you would normally do. So you don't have to bring one down for this case because we got two terms here. You know what I mean? So now I'd go up to the top, put an x, and go, is that going to work? X times x is x squared. Ooh, that's close. I just need a 6 on it. And then the 6 times x makes 6x squared. 6x times the 2 is going to make plus 12x. Draw the line. Opposite, opposite. That's going to be negative 16x. And now I got to bring down the last thing, plus 9. And remember what I said, if this thing factors, it probably is going to work. This one doesn't factor, so it's probably not going to work, meaning you'll have a remainder. Just so you know, on the test, if you get a remainder, that's okay. There's sometimes we put problems on the test that work and have a remainder of 0. And sometimes we have problems where there is a remainder and it's fine. Just write down your answer that you get for the remainder. Okay, so now where was I? I always put an x here and then I realized sometimes that it's too much. Yeah, x times x is x squared and that's not what I wanted. So I didn't really want an x. I really wanted a negative 16. Negative 16 times x makes negative 16x. And that's where I forgot to erase the squared last time. And then negative 16 times the 2 makes negative 32. Draw the line. Don't forget your opposite, opposite. Opposite, opposite. And then 32 and 9 makes 41. Remainder was 41. So on the test, I'd be looking for, this was the quotient with a remainder of 41. So on your homework, I will tell you ahead of time. There's 2 that work, meaning they have a remainder of 0. Those are always satisfying. Seems like those are the kind that work. And there's 1 that has a remainder. So it's not wrong just because, you didn't get 0 at the end. All right, let's start that homework right now. Number 1, there's only 4, and I'm having you skip number 4. So you literally only have 3 questions. So please, right now, pull up the worksheet. Once you get started with me, you get the first problem like halfway done. I'll give you a whole bunch of work time, but it's not work time yet because we're still doing that first problem together. So don't take out cell phones yet. I know it's a pain in the butt to read, but you're good at reading. Would you read me number 1? What goes on the outside? What's a little x minus something?
2x to the...
No, on the outside. Like on the outside of the big parentheses. It's what's divided by at the end.
Oh, x plus 4.
Plus 4, thank you. And then what goes on the inside?
2x to the 4th power plus 11x to the 3rd plus 13x squared plus 2x minus 8.
Awesome, thank you. All right, I'm glad there's only 3 of them. They're just tedious. All right. Henry Nichols, what do we always start with?
We first start off with the first number. You can basically find what they're both going to, pretty much.
Okay, so I said usually start with an x, and in this case that's not enough because it'll only make an x squared. So what do you think it should be?
I said that it was 2x squared root of 3. No, 2x squared root 3.
To the 3rd.
Oh yeah, so it's a third.
2x to the 3rd. Good, and then this times this makes 2x to the 4th, and then what?
And then of course, you bring it down to 4. That'll turn into 8x3.
Yes.
And of course, you also have to flip it.
Ooh, yes. Opposite, opposite. Okay. Now what?
Now you cancel out 2x 4.
Yep.
And then of course that turns into 3x to the power of 3.
And then I'm just going to stop right there because I think you get the idea. Bring this down. Then you think of a number. I say always start this with an x up there. And then you go, ooh, maybe I need a number in front of the x. Okay. All right. All right. You've made it. That's all I got for you for today.